In this video, we're going to finish up our discussion of law of sines, showing a few applications. Okay, so for a a right triangle, for a right triangle, our area usually is always this, base times height. Now, you guys in high school geometry dealt with a bit of this, that when they give me a triangle like this, right, that this is not my height, right? For this kind of thing. The same with this triangle here. This is not my height. The height is the h there. It's the perpendicular. So when I have a oblique triangle, this formula kind of falls apart because I have the base, right? Our base in both of these are b, but I'm going to have to do some trig to find the h. So let's just do it up front and then get a formula for it. All right, so take a look at the triangle over here to the left. If I needed to find h, I could do sine of alpha equals h over c. And if I solve for h, I get c times sine of alpha. So that's what they did over here. So they did base is b, right? That's the bottom of this triangle. And then they replaced the height with what you and I just came up with, right? And it's the same for the other one. If it is a triangle that is inside or outside like that, or this one could be done the same way. Same argument could be made. I'm not going to go through the second one. It's a little more involved, and typically I found out when I do that in class, most people glaze over when we're face to face. So if you'd like to play with that second triangle to maybe come up with the formula that they have, please do. All right, so here's the formulas. Notice that the two that are out front are the ones not associated with the angle given, like sine alpha, then we get BC. And no A, little a. Sine beta, I have AC, no B. Sine gamma, I have AB, no C. All right. So they said find the area of a triangle, and they have A, B, and C, and gamma, they have the angle. So I have to find my third side. So what they give us? All right, so I'm going to go ahead and draw my triangle. I need to see what I have. All right, so alpha, beta, gamma, 90, 52. All right, and then they gave us this 102. All right, and I really just need to find that other side, so we'll call it little c. Now, notice that I actually have enough info to do law of sines. So sine of 102 degrees is going to be over c. Do we have enough info? Give me a sec. I think I messed up somewhere. Let me draw out my chart. I'll show you how it actually helps me out. Alpha, beta, gamma, A, B, C. Okay, so I have 90 here. And then across from beta, I have 52. And then across from gamma, I have 102. All right. We actually have enough information. Just realized I don't know why I thought I needed A, B, and C. But if I have A and B, then the formula that we're dealing with is right here, which requires gamma. I don't even need to do everything I did. I took you guys on a wrong path. Forgive me, making it more complicated than it needed to be. Story of my life. And then I plugged in the wrong thing there. Little a is 90 times little b, which is 52, and then it's going to be times the sine of 102 degrees. All right, so this is going to be roughly, we're going to get a decimal, so I'm doing approximate. 0.5 times 90 times 52 times sine of 102. All right, I got 2288 point. Did they tell us to round the area to the nearest integer? So 89, I think. Let me pull that back up. So that's going to be an 89, like I said. So 89, and then it is, they didn't give us units. So units squared for area. Okay, so don't overthink this like I did. We need two sides and then the third angle. And I just noticed, you guys probably, somebody noticed, I know definitely, this was down here, not A. If it would have been A, I could have found the other side using law of sines, but I don't need that. The formula calls for the two opposite sides from the angle given. Cool. All right, so that's how you find area. It's just a formula. Okay, they have one more here. Notice they have A, C, and beta. So area is equal, I'm going to write the formula. 1/2 times A times C times sine of 42 degrees. So I get 1/2 times 7.2 times 3.4 times sine of 42 degrees. Okay, that's going to give me a decimal. I got 0.5 times 7.2 times 3.4 times sine of 42. 8.2. Right? And they did give us units here. It's not bad. You just got to plug it in. All right, I have two application problems that aren't area. It's for finding altitude of things. So find the altitude of the aircraft, and the problem introduced at the beginning of the section. We didn't look at that. I didn't use the book problem. Round the altitude to the nearest tenth of a mile. So what they're wanting us to do is find the altitude, which is just the height of the plane. Okay, so here's one thing I got to get across. This is 20 all the way across. So if it was just 20 across the bottom of this, then we'd be practically done. Right now, I see that I have 15 degrees. I can't use the law of sines directly to find h, but it would be nice if I had h, because if I had h, sorry, I'm looking for h. If I had a, then I could just use the right triangle, right? Because I don't need this for that. I would just use a sine. But the problem is I don't have a. So that's where we're out after. All right, so let's go ahead and label everything. Alpha is 35 degrees because that's across from A. A we don't have. Beta is our choice. So I'm going to call that the 15 degrees, little b. And then gamma we don't have, but we do have little c. Cool. All right, we can find this does not have what we need for law of sines. We need this angle with that side, but we can add them together, 40, 50. So 130 is my angle. This checks out with our picture too, being pretty wide there. So what we're looking for, I don't really care about that. I just need A. If I find A, then I can find H. So sine of 130 degrees over 20 is equal to sine 35 degrees over little a. So little a is going to be equal to 20 sine of 35 degrees over sine of 130 degrees. All right, pull our calculator up. 20 sine of 35, close it, divided by sine of 130. I got about a 14 point, let's go, it says nearest tenth, so I'm going to keep a little bit. We'll do 14.975. 975. That's not my final answer. That's why I'm not rounding as hard. So 975. Now I have A, so I can just use straight up trig. My little triangle here, I got a triangle there to find H, and it's a right triangle, so that's why I get to just set up my straight trig ratio. H over 14.975. So that means H is 14.975 times sine of 15 degrees. This will give me my H. Right, so pull my calculator up. 14.975 times sine of 15. Right, that got me a 3.8, and they said round it, so we'll go 3.9. And this may seem like, hey, that's pretty small, but remember this is miles, right? And if these angles aren't very big, then it's not going up very high. Okay, so there's our altitude. We have one more application. We'll be done with this section. The next section deals with the same scenario, but given different things to begin with, like different A's, B's, and C's. They won't line up for law of sines. We'll actually have a law of cosines. All right, one more problem here. This is some geometry in this problem. Notice my triangle AB, and they didn't label it, but we'll call it C up here. A, B, and C. A pilot is flying over a straight highway. He determines the angles of depression to two mileposts 5.2 miles apart to be 34 and 46. Okay, so they labeled it. Now, here's the deal. We can actually get the angles inside the triangle by doing this. So remember from high school geometry, we have two parallel lines with a line running through it. This is like classic high school geometry. I know that this angle right here is the same angles right there, called alternate interior angles. Which means if that's 46, this is also 46. Same argument can be done over here, right? That is that same idea. This is equal to that. So this is equal to 34 degrees. So I'm going to list out that they want the elevation of the plane. We didn't even list that, right, that part. We want the H that goes right down the middle. All right, we don't have one of the sides here or here, so I can't just use right triangle trig. So I'm going to need to find, again, if I can find this little a here, then I can find H. Okay, so that means, let's set up, we need law of sines. We also will need this angle here. But if you notice that all three of these add to 180, so all I got to do is subtract it. So that's 50, 50, 80. So this is 100 degrees. 100 degrees. All right, so that means sine of 100 degrees, and we have the side. The reason I'm using 100 is because we have 5.2 all opposite, over sine of 34 degrees over little a. If I can find little a, then I can just use right triangle trig to find H. So 5.2 sine of 34 degrees over sine of 100 degrees. And that's going to be roughly something. All right, 5.2 sine of 34, close it, divided by sine of 100. Okay, I got about a 2 point, and I'm not going to really round here, 5266. I think that's probably enough to give me a whole number in the end that's going to be accurate. So now I use that, that's A, I can just use right triangle trig. Sine of 46 degrees is equal to H, all right? And we don't have H, that's what we're looking for. And then over 2.95266, which means H is just going to be the product of those two numbers. So since I just grabbed that number, I'm just going to take it and times it by sine of 46. Okay, I got about a 2.12. They want us to round to the nearest whole number, so round 2. And I'm guessing that it is miles, yes. So 2 miles above the ground. Pretty far up there. All right. Applications really will be coming down to, you know what you need for law of sines. Is there a way that you can take your picture and get what you need by manipulating using geometry for the most part? All right.